Hello everyone, and my topic is chemical mystery for the multi-asteroid target exploration. Nowadays, multi-asteroid explorations gradually attracting many studies and analytical. The second mission is a typical multi-asteroid exploration. She flies by the two asteroids and the family made with a comet. The second mission is that we can get more useful information from the asteroid explorations. So it carried many projects to do that things. China now try to make a first multi-asteroid project. But I think we need find some new paths from exploration to application. However, before we make a change, we have to conquer some problems. For the asteroid projects, we also find the cost is expensive and time is very long. For missionaries, the multi-body exploration brings high complexity. For example, the dynamic behaviors become chaotic. Launch windows selection become difficult, and so on. So we think we have an idea to resolve these problems. A multi-asteroid exploration based on cubesat is now developing, which can reduce the mission cost and decouple the complexity. We do some ways to develop our idea. We propose a mission strategy formed by a cubesat site from Sun Earth L2 or Earth Moon L2 elevation points. There are three phases. Now, the first phase to the Earth Moon L2, and then we can go to the Sun Earth L2, and then we fly to the asteroid. There are also two strategies. The first, directly transfer to the Sun Earth L2 halo orbit from Earth Moon orbit, and the second, transfer to Earth Moon L2, and then transfer to Sun Earth L2. There is a known technology application. We can use for the Sun Earth L2 strategy. We can use the pseudo-manifold to transfer. And usually it will take a very long time. But by increasing the participation, we can shorten the time. For the Earth Moon L2, we use the LS to connect the halo orbit. This transfer trajectory memory principle is the model CRTDP. And we also make built trajectory searching method. This some model. We use the planetary gravity-assistis and asteroid. And this objective function. So use this base, we do example and test our idea is available. We firstly choose the target asteroid, and this detail this asteroid. And then we searching for the escape time date. The initial orbit is the Sun-Earth L2 northern huddle orbit. With the integration, we're searching the optimal solutions. Finally, we find that the most total database is about 1.5 kilometer per second, and the total time is about 200 days. These transfer trajectories. We also choose another asteroid for the multi-asteroid exploration. We can see usually the total database for transfer to asteroid is lower than 1 kilometer per second. We also do some cubesat concept. We choose a payload optic and advanced camera. These details of cubesat configuration. We believe 150 kilogram spacecraft can apply about 1 kilogram per second weight. Finally, we choose a launch vehicle. We choose a Chinese launch vehicle, 4C. According above description, we make a mission profile. Firstly, we fly to DMI2, and second, we fly to the SEL2, and then we can fly to a multi-asteroid. So we can independently apply the 6 cubesats asteroid mission teams for scientists, launched by one rocket. And each mission, according to our calculation, only costs $20 million. This is including manufacture and launch. Summary. We built an economical asteroid exploration project. And we first put the cubesat as a primary payload first. And we can detect multi-targets by a side of cubesat with orbiting hollow orbit. And we propose 2 candidate strategies: Sun-Earth L2 base and Earth Moon L2 base. A smaller database than that of the classic mission. Further, we will do the research about real underspace model and low-dust entity, and we do the more detail about this project. Okay, thanks.
Questions, please?
Thanks for your talk, very interesting study. If I've understood correctly, the delta V capability of the spacecraft is about 1 kilometer.
Yeah.
So, did you have a look at how many targets you could reach with how many?
We firstly choose a fixed asteroid. So based on the launch vehicle, and based on the we choose Earth Moon L2 or Sun-Earth L2. just we decide a line, exactly a line. So we think now, according now technology, we think 50 kilogram spacecraft can arrive 1 kilometer per second. So we select a lower trajectory, 1 kilometer per second to this asteroid.
Targets do you think you can visit?
We just choose six asteroids. We don't do a more research to see how many. Yeah.
Any further questions? No? In that case, let's thank the speaker again.